Dear students, after the discovery of the two fundamental particles, electron and proton, it was felt necessary to establish this position of these two subatomic particles, electron and proton, inside the atom, because atom is electrically neutral, is the smallest particle of the element, and these electron and proton are present inside the atom. So where are they inside the atom? And if they are there inside the atom, then how are they? So before talking to you this, let me tell what was the development going on at that time in the world of science. It was 1905, 1900, around that the configuration of the electron proton was confirmed, and at that time the radioactivity was discovered by Henry Becquerel. There are some elements called like uranium, thorium, they are spontaneously undergoing disintegration, producing very powerful radiations which are more penetrating than those of the cathode rays, and those rays were called as alpha rays, beta rays and gamma rays. These alpha rays have 2 units of positive charge and 4 units of atomic mass, and gamma rays, beta rays all have 1 unit of negative charge, no mass or negligible mass, and the gamma rays are electromagnetic radiation. This was the discovery made by Henry Becquerel during that time. And on the other side, the inert gases were discovered: helium, neon, argon, krypton, xenon and radon. And Cosell proposed the rule of octet, that electrons, the atoms of every element, have a strong tendency to attain octet in their outermost shell, either by losing electron or gaining electron, or by contributing and sharing electron in order to attain chemical stability. So these are the discoveries, they are going on at different places of the world, and all the scientists, they are in communication. Then question comes, how is the atom? How is the atom? What is there? How this, if the atom consists of two particles, electron, two types of particles, electron negatively charged and having a very negligible mass, which is 1 by 1837 times the mass of an hydrogen atom, and proton, a positively charged particle, which is equal to the mass of the hydrogen atom. And how are they? They are inside the atom. So attempts were made by the scientists to propose a model of atom. What we mean by the word model? Because nobody can see the atom, because the atom is the smallest particle which cannot be seen. So, but how the atom looks like? How the atom looks like? You have Taj Mahal. Those who go to Taj Mahal, they see the Taj Mahal. But in distant places like New York City or Washington or London, a person wants to know what about Taj Mahal. Then what is does there? Exactly, Taj Mahal is made by plaster Paris, and exactly from the photography everything is kept, and people were made to understand this is Taj Mahal. So that they call as a model of Taj Mahal. So exactly here attempt was made to configure the position of the two fundamental particles, electron and proton, and that is called the model of atom. And it was the Rutherford, he proposed a model of atom called as Rutherford nuclear model of atom, that we are going to discuss. It's a very important topic for the students of science. What the Rutherford has told in the year 1911 till today, neither the position of the electron, position of the proton or this remains same, but the other developments has taken place inside. So he had a penetrating vision to the unseen future and proposed a model of atom called as Rutherford nuclear model of atom. So we are going to study today the Rutherford nuclear model of atom. And he proposed this model of atom in the year 1911 from his experiment called as scattering of alpha particles. In the year 1911, in order to configurate the position of two fundamental particles, electron and proton, inside the atom, a model of atom was proposed by Ernst Rutherford. His name is Ernst Rutherford, from the experiment scattering of alpha particles by a thin metallic gold foil called as Rutherford nuclear model of atom. So I am saying here, in order to configurate means establish the position. The configurate, where is this? Where are they? Configurate the position of the two fundamental particles, because by the year 1911 the electron and proton were discovered only. The neutron was discovered in the 1932. So only two particles were known during that time, fundamental particles, electron and proton. Inside the atom, a model of atom was proposed. That is a model of atom proposed. He thought how the atom, inside the atom, how are they? So that is called the model. From the experiment called as a scattering of alpha particles by a thin metallic gold foil. He carried out an experiment, very inventable, incredible experiment. I can say the world of science will be remembering for all time to come this experiment, because the first step in the ladder of the structure of atom to explain the electron and proton position inside the atom. So he carried out an experiment called as scattering of alpha particles by a gold foil called as Rutherford nuclear model of atom. So what is this scattering and what is this gold foil? So gold is a metal which is highly malleable and ductile. He has chosen the gold. He took the gold to carry out the experiment. Somebody may question, why not copper, why not iron, why not? Because it is highly malleable and ductile and has a glittering surface, and we can go on beating the gold to prepare a thin plate, possible as much as possible thinner plate can be made. because he thought, how is the atom? What happens in a metal? How are the atoms? The atoms are just arranged in layers. So these are the atoms. So they are arranged inside the, like this. The atoms are arranged in layers inside a metal. So there is no gap between the atoms. So if he went on beating the gold foil, now here thin plate, then what will happen? All the atoms are very, very close to them, and now he wanted to bombard in the alpha particle. What is this alpha particle? This alpha particle is the helium ion having 2 units of positive charge and 4 units of atomic mass. This is the alpha particle. Why chosen the alpha particle? Why not beta particle? Now beta particle is electron, is a mass, a no mass, negligible mass, and here alpha particle is has 2 units of positive charge and 4 units of mass, and it is moving in a velocity almost equal to the velocity of light. Imagine a gold foil will be kept, and these alpha particles will be allowed to strike upon this, which are moving with a velocity about equal to the velocity of light. So we know that when a particle is moving with a particle with mass is moving, then it has a lot of kinetic energy, half mv square. So imagine what must be the energy associated with a alpha particle when it is moving, and it moves in straight line. So then he thought, he took the gold, that is the gold foil, because gold, another one, and gold important property, it remains unaffected by acids and bases. Even concentrated nitric acid does not have any action upon the gold. Hence the gold metal remains in the atomic state. It is remaining in the atomic state. Hence whatever observation the Rutherford will now make, he'll make the observations of due to an atom. But if you take copper, if you take iron, if you take silver, they will react with the atmospheric oxygen to form their oxides. It will be a compound. Then observation will not be related to an atom. So very, very consciously he has chosen the gold foil and thin gold foil. So he has taken a gold foil of 400 angstrom unit atomic angstrom unit thickness. 400 angstrom unit thickness means 1 angstrom unit is 10 to the power minus 8 centimeter. That means it is almost 0.0004 centimeter thickness. He has prepared the gold foil. Then he carried out an experiment where the alpha particles were scattered. When the alpha particles were bombarded upon the gold foil, they scattered. They did not go in the straight line. But the scattering of alpha particles, bichurana, we call in the bichurana, pada ame ଓଡ଼ିଆରେ use କରୁଛୁ. Bichurana ବୋଲି Sanskrit, Hindi ସବୁଥିରେ use ହେଉଛି. Exactly that has happened. So that experiment is called scattering of a particle, and from there he proposed this model of atom called as the nuclear model of atom. So let me explain you what is the scattering of alpha particle, how he conducted the experiment. He took the gold foil and in a box and allowed these alpha particles to penetrate through a pinhole. So how they took, suppose they took the gold foil. The gold foil was taken. The gold foil was taken of 400 angstrom unit. The thickness of the gold foil is about 400 angstrom unit is its thickness. So small is this. Then what he did, he covered this all around in a box. In all the sides of box, it is a box. In the box he kept this, and all the sides of the box are covered by zinc sulfide. They are covered by zinc sulfide, because we have discussed during the discussion of electron and proton, when these cathode rays or the positive rays strike upon zinc zinc sulfide, they produce fluorescence. They produce a bright blue, greenish blue light. So when the alpha particle will come, hit upon the gold foil, if anywhere it goes, he cannot see the alpha particle. Alpha particle cannot be seen by the naked eye. The beam of alpha particle will allow to enter and strike the gold foil. And all around he covered the box with zinc sulfide. So these alpha particles, they will go strike this zinc sulfide screen all around the box. And he was bringing through another lens. He prepared a box and kept the gold foil in the middle, made a pinhole, allowed these alpha particles to enter through this, and was observing through another lens, pinhole lens fixed in pinhole, what is going on inside that. That is called the scattering or experiment of this scattering of alpha particles. So when these alpha particles, they were bombarded with thin of moving with very high velocity, as good as almost to the velocity of light, and their velocity was accelerated by and they were allowed to strike upon the metallic plate. And when it is observed, what observation he made? He found that most of the alpha particles penetrated the gold foil. Means these alpha particles, they come and they hit upon here the zinc sulfide. They come and hit upon the zinc sulfide. They hit upon the zinc sulfide. Here he got the scintillation, or here he got the fluorescence. So he found most of the alpha particles, they come and they are producing fluorescence here. Means they are remaining undeflected. They are moving in same straight line as they were entering into the box. They went undeflected. So these alpha particles are remaining what? Undeflected. So most of the alpha particles, they remain undeflected. Then second observation made, some of the alpha particles got deflected in smaller and larger angles. So this some of they come, and when they come here, they went like this. And some they come and they hit the foil and they went like this. And some they come and they hit the foil and they went like this. And here also some they come, they hit and they got deflected in smaller and larger angles. So these alpha particles, they got deflected in smaller and larger angles. Two observations. Then what a third observation? The third observation was very interesting, that 1 in 10,000 of the alpha particles, one alpha particle in 10,000 of the alpha particles got back deflected or retraced their path. Means this alpha particle went straight, hit the gold foil, again it went this path, again it came back in the same path. Then what we understand here, the angle of deflection, it should have gone like this. So this angle of deflection is almost 180 degree. So these are the angle of deflection, they are moving. So this smaller and larger angle. So we can record these three observations, that the first what it did, first observation he made, most of alpha particles went undeflected, penetrating the gold foil. They penetrated the gold foil and went undeflected. Then second observation he made, some of the alpha particles got deflected in smaller and larger angles. larger angles, smaller and larger angles. And third observation he made, that very few of alpha particles, that is 1 in 10,000, 1 in almost 10,000, got back deflected, or retraced their path. Means here the angle of in the same path, their path, in the same path in which they went, in the same path in which they went, again they came back in the same path. They retraced, in this is a retracing of, so here it is back deflected or retraced their path. So very important. These are three observations he made from this. How he got this? So here they are hitting the zinc sulfide here. So he was seeing the fluorescence, and some they came and hit it down. So he found, and here he has a this side he has a board this and zinc sulfide, and it came and struck here, and he got this. So from all these fluorescence produced on the zinc sulfide screen, he could configure that the alpha particles, that is scattered. They are moving from a small beam and they are now getting in different directions. So hence the experiment was called as scattering of alpha particles by a thin metallic gold foil of 400 angstrom unit. And this is a brilliant experiment he made, which led to the conclusion. So from one observation he has to conclude this, and three conclusions made about this, three observations made. So now we will what are the conclusions were made by Rutherford? What conclusions made? So first, the Rutherford concluded, in order to conclude these observations, so he says, first, since most of the alpha particles are penetrating the gold foil, and went undeflected, hence there must be a large hollow space inside the atom. Inside the atom there must be a large hollow space. So they are going straight. There is no deflection, there is no change in their path. Somebody may question, sir, there must be gap between. No, there cannot be a gap, because in a metal, if you look to a metal, take the X-ray of the metal, it comes very plain, and there is no interatomic space inside the atoms. And to the his satisfaction, what he did, he prepared a thin metallic gold foil. He went on beating it and prepared a thin 400 angstrom unit, 0.0004 centimeter thickness. Then what will happen? There is no interatomic space. If at all they are penetrating to the atom of the gold atom. They must be penetrating to the gold atom. That confirmed him that there must be a large hollow space inside the atom. Then second observation, some of the alpha particles got deflected in smaller and larger angles. What are alpha particles? They are positively charged. What the atom consists of? Atom consists of protons and electrons. So these alpha particles must be coming closer to the protons present inside the atom, and like charges ripple, hence those protons present inside the atom must be causing the repulsion, because there is a mutual repulsion takes place when a one positively charged particle comes around another particle, and the mutual repulsion takes place, and which causes the deflection. So since what he told, since some of the alpha, not all the alpha particles, very few, some of the alpha particles, I mean those alpha particles, they come to the close proximity of the positively charged body present inside the atom because of mutual repulsion, the deflection of alpha particles take place. Then question comes, why smaller and larger? Because those alpha particles, they come closer to that positively charged massive body present in the atom. The repulsion will be maximum, hence the angle of deflection is more. And those who come little distance, the angle of deflection is less because the repulsion is less. So since, I concluded, second observation is concluded, since the alpha particles are associated with 2 units of positive charge, 2 units of positive charge and 4 units of atomic mass, there must be a positively charged massive body positively charged massive body present inside the atom, causing these deflections in smaller and larger angles due to mutual repulsion. So he says now, from this he says, since alpha particles are associated with 2 units of positive charge and 4 units of atomic mass are undergoing deflection, hence there must be a positively charged massive body present inside the atom. Means these protons must be concentrated at one place of the atom and forming a positively charged massive body. So they are not a different place. Protons are not different, because Thomson has already told a Thomson model which was rejected because he configured that what? The electrons and protons are distributed on the surface of the atom. No, according to Rutherford, they are not distributed, they are concentrated. All the protons, they are concentrated at one place and they are forming a positively charged massive body at one place of the atom. And when these alpha particles are coming closer to this positively charged massive body present inside the atom, there undergoes mutual repulsion between that positively charged massive body due to the protons and the alpha particle. Hence there is a deflection. Those who come nearer to the positively charged massive body, the angle of deflection is more. Those who are at a distance from the positively charged massive body, the angle of deflection is less. So he concludes. So he says what? There is a positively charged massive body inside the atom. So he says now, so there is a positively charged massive body inside the atom, and all around the atom there is a large hollow space, he says. So here they are inside the atom, there is a large vacant space. There is a large hollow space inside the atom. So those alpha particles, they come through the hollow space, they are penetrating like this, and they are going undeflected. So there is a large hollow space present inside the atom, and hence these alpha particles are penetrating the gold foil. And those alpha particles, they come closer. Suppose the one alpha particle come closer to this. One alpha particle is coming closer to this. So then this will repel this. Hence it undergoes repulsion. So this should have gone like this. But because of mutual repulsion, this is the angle of deflection. This is the angle of deflection, and it went like this. And those who went like this, so or still closer, the repulsion is more. This should have gone like this, but this should have gone like this, but the angle of deflection is more because of mutual repulsion is more. And those who come nearer to this, the angle of deflection is less, and like this. And those who still go nearer to this, the angle of deflection is still more. Those who go nearer to this, the angle of deflection is still more. So this is they are deflected in smaller and larger angles, and this is the penetration of the alpha particles through the vacant space. So he says now this positively charged massive body must contains what? The protons. So what is this? This is a positively charged massive body present inside the atom, which is causing this deflection of these alpha particles. Then comes the third observation he wanted to conclude. What is the third observation? So this angle of deflection or the extent of repulsion depends upon what? Their close proximity. The proximity of the alpha particles. Those who come very nearer, the repulsion is more, angle of deflection is more. And those who come little distance, the mutual repulsion is less, so they go, the deflection is less. Very convincingly he could conclude his observations, which led to the discovery of very important model of atom, that is the Rutherford model of atom. Now to confirm third observation, so those alpha particles, they go very close to the positively charged massive body. They go to approach the close proximity of the positively charged massive body. Those are very few of the alpha particles he found. 1 in 10,000. So that they went, and what happened to them? They came back in the same path. So this is what? Back deflected. This is the back deflected or retraced. They retraced in the same path, retraced of the path. In the same path they came back. Means what? This repulsion is 180 degree. Here the repulsion becomes 180 degree. In some the repulsion is more than 90. In some the repulsion is less than 90. And in 1 in 10,000 got back deflected. So these three wonderful observations he made, and he gave these conclusions. So that those atom, since most of the Hall particles are penetrating, so there must be a large empty space inside the atom, hence they are penetrating the gold foil. And second, and they are undergoing deflection. To account for the deflection he proposed, the atom consists of the protons. All the protons must be there, placed at one place of the atom, concentrated at one place of the atom, causing a positively charged massive body. And when these alpha particles come nearer to that positively charged massive body present inside the atom, these deflections are taking place. And when 1 in 10,000 when come back deflection, retracing the path, when they come very close proximity of this positively charged massive body. So now question comes, because this positively charged massive body present inside the atom must be very, very, very small in comparison to the total space of the atom. If you compare the size of the atom, this positively charged massive body present inside the atom must be very, very small one. Very, very small one means a very small space. All the protons are concentrated. So all these observations, all these three observations are because of what? Because of this positively charged massive body. So he, from the language of English, he got a name for this positively charged massive body called nucleus. Nucleus, because all these observations are originating, because of this positively charged massive body. Because the positively charged massive body is very small, so there is a large empty space inside the atom, and which causes the penetration of the particles. And the positively charged massive body is very small, hence that mutual repulsion is maximum, causing deflection. Hence he called this positively charged massive body present inside the atom, he named this positively charged massive body inside the atom as nucleus. He called this as nucleus. This positively charged massive body was named by nucleus. Many often people say he discovered a nucleus. No, not discovered the nucleus. He discovered the positively charged massive body present inside the atom and named it nucleus. So the nucleus name was given to that positively charged massive body present inside the atom by Rutherford as a nucleus. So if children, it is very important for a student of chemistry to understand the meaning of the words used. If once a student starts learning the meaning of the words written in the sentences of the book, then he can earn the knowledge and become and the wisdom. But if you read and say that nucleus was discovered, if you don't feel the charm of the nucleus, if you don't feel the warmth of nucleus, why the nucleus word was used by Rutherford? Many often people say he discovered the nucleus. What is discovery? Something is there and he went and got it and found it and discovered. So that is called discovering. No, it's not discovering. He discovered the positively charged massive body present inside the atom, and very wisely he used the word nucleus. Mother is the nucleus of the family. Mother is the nucleus of the family, because the father comes, tell the mother, the children go tell the mother. The mother takes all the care of the family. The entire family constitution depends on the mother. She builds the house. She is the architect of the family. Hence, she is called the nucleus of the family. So she doesn't contain positive charge in it. One should not feel she is a massive positively charged body present inside the house. She sees the origin of everything that good and bad happens inside the atom and supporting the entire family. So this nucleus is supporting the entire atom. The atom in which the nucleus is highly stable, the atom is very stable. The stability of the atom is the cause of the stability of the nucleus. Just like the mother is the nucleus of the family, so we see the architect and keeps everybody at one place, and he keeps the bonding of every family is related to us. So everything is related by this nucleus. These electrons are very, very, how the nucleus are controlled by the atom, by this nucleus. So taking this into account, these observations, he proposed a model of atom taking nucleus as the, giving nucleus as the importance. He made a model of atom and he called as the nuclear model of atom. That is the reason it is called a nuclear model of atom, because giving importance to the nucleus, keeping all the concentration on the nucleus, he proposed a model, not prepared, proposed a model of atom, hence he called it the Rutherford nuclear model of atom. So next class I will explain you the dimension of nucleus, dimension of atom, and how are the electrons, and how the electrons are there inside the atom, and how this atom is a stable atom was model of atom was proposed by Rutherford in our next class.